Good day, class. Today we're going to continue off where we left off yesterday. I planned on getting a little further, all right, but we didn't get there. So we'll go ahead and start anew today. All right, so today we're going to talk about graphing cosecant, secant. Primarily, we can do those fairly easy, and then we'll just do the basics of tangent and cotangent. All right, we won't get too deep into those. Sine and cosine are used very frequently to model real world situations. The rest of these are not, so we won't get too crazy into them. Although cosecant and secant are actually quite easy once you know how to graph sine or cosine. So we'll go ahead and talk about that a little bit here. All right, so first we're just going to start off with kind of the parent function of graph y equals cosecant of x. All right, well, what do we know about cosecant of x? The main thing we know about cosecant of x, all right, is that cosecant of x is equal to 1 over sine of x. All right, so we know that they're just reciprocals of each other. Okay, so what we're going to want to do first is actually just go ahead and graph sine of x. All right, so we'll go ahead and go through. Of course, this is a very basic one, right? With our a equals to 1, our b is equal to 1, our c is 0, and our d is 0. But we'll go ahead and find all of our pertinent information anyway. So our amplitude, of course, is the absolute value of a, which in this case is just going to be 1. Our period, right, is equal to 2 pi over b. Of course, my b is also 1 here, so it's just going to be 2 pi. All right, our intervals, we take our period and divide it by 4. So, of course, that will reduce to pi over 2. All right, our baseline is our d, which is missing here, which means it's 0. Our start is our c over b. Of course, our c is missing also, which means it's 0. So 0 over 1 is 0. And our end is our start plus or minus the period. So negative 2 pi and 2 pi. All right, so I'll go ahead and get started here. We'll give ourselves an axis. Right now we are starting on 0, so I can just go ahead and make that the y-axis here. So I know my amplitude is just 1, so I'm just going up to 1 and down to negative 1. All right, I should have 1, 2, 3, 4 ticks to the right, and 1, 2, 3, 4 ticks to the left. Of course, I know each of these is pi over 2, so this is 1 pi over 2, this is 2 pi over 2, 3 pi over 2, 4 pi over 2, which reduces to 2 pi, and it'll happen similarly over here. Of course, this is just 1 and negative 1 here. All right, so if we were to graph sine, all right, it starts at 0, and sine always starts on the baseline. All right, of course, I can also put some guidelines up here at the max and min. So that will go here and here. All right, and of course, the baseline is also one of our guidelines. All right, so graphing this, I start at 0 and sine starts on my baseline. My a was positive, so I go up first as I go to the right. Then I just follow my pattern as normal. I would follow this pattern, so I'd be going down to the left here. All right, and I connect this with a nice smooth curve. All right, and there is the sine graph, which we all know and love. We've seen this plenty of times before. Of course, here we're really trying to do cosecant. Now we know cosecant is the reciprocal of sine, right? So we're actually going to have some problems here whenever this is 0. right? So whenever sine is 0, that means I'm going to have a 0 in the denominator, which hopefully we remember from rational functions is going to give us a vertical asymptote, all right? So wherever this is 0, I'm going to have a vertical asymptote. So vertical asymptote there, vertical asymptote there, vertical asymptote here, and here. All right, so there are some vertical asymptotes. I guess I would have another one here as well. Might as well kind of finish it out. All right, so, and now we have basically just the reciprocal, right? So of course the reciprocal of 1 is still 1, so this is 1. But then like 1/2 would be 2, 1/4 would be 4, right? So on and so forth. So actually all we have to do here, right, is follow these asymptotes and use this point, which would be both of them, and it will look like this. So this is our graph. The red part here is the graph of cosecant. And that's it. All right, so what about 2 secant? All right, well, what do we know about secant? All right, well, we know that secant of x is equal to 1 over cosine of x. So what I'm really going to do here first is graph 2 cosine of x. All right, so again, we'll find all of our pertinent information. So our amplitude here is going to be 2. Our period, since my b is 1 again, 2 pi over 1 is just 2 pi. Our intervals, 2 pi divided by 4, again, is pi over 2. Our baseline, again, there's no d, so this is 0. Our start, again, there's no d, so this is 0. All right, and our end, of course, is just our start plus or minus our period. So again, is I guess I don't have to write it like that, would be negative 2 pi and 2 pi. All right, so our kind of axis and stuff here is going to look exactly the same as it did last time. All right, except now, of course, my amplitude is 2, so I'm going to have to come up to 2 and down to negative 2. I again will have 1, 2, 3, 4 ticks to the right, and 1, 2, 3, 4 ticks to the left. Again, these are all pi, half of a pi, so every 2 is a full pi. All right, again, I can put my guidelines on here. All right, so my max is going to be up here at 2. My min is going to be down here at negative 2. And of course, my baseline here at the x-axis. All right, of course, cosine starts at the maximum or minimum. My a is positive, so I'm starting at the maximum, and it tells me to start at 0, so 0 in the maximum. And then, of course, I follow my pattern down to the baseline, down to the minimum, back to the baseline, back to the maximum. Follow this pattern over here. All right, and we go ahead and connect this with a nice smooth curve. That was not a nice smooth curve at all. All right, so there's our cosine curve. But again, we really wanted to do secant here. We just do the same thing. All right, wherever my zeros are going to be oops, didn't want that, are going to be vertical asymptotes. All right. So try to even these up a little bit more. All right. And then essentially we just do the same thing that we did. All right. And even when you have vertical shifts and things, you're still going to count your baseline as your zero, quote unquote. And that's going to be wherever your baseline points are, is always going to be where your vertical asymptotes are. So we just do the same thing that we did here. Of course, we didn't finish this side over here, but it would do the same thing. And that's it. So that's how you do all secant and cosecant. All right. You just graph its reciprocal, whether it be sine or cosine. And then once you graph it, all of your baseline points become vertical asymptotes. And you make these, they look kind of parabolic, right? They're not actual parabolas, but they are parabolic in shape. So, and you just make those above the maximum and minimum points, above and below, right above the maximum and below the minimum points. And that's it. You're done. All right. So now I'll go ahead and skip this one and go to this one that has like a lot going on, right? So we'll do like a much more complicated one. Okay, so of course, I'm just going to do cosine here, since cosine is the reciprocal of secant. All right, so my amplitude is the absolute value of -2, which is 2. My period is going to be 2 pi over b, so 2 pi over 1/2. Of course, when you divide by a fraction, you can multiply that by the reciprocal. So you can multiply 2 pi by 2 over 1 and get 4 pi, right? Which means our intervals, 4 pi divided by 4 is just pi, all right? Our baseline is -4. Our start is c, which is pi over 3. Divided by b, which is 1/2. Of course, when you divide by a fraction, you can multiply by its reciprocal. So this is 2 pi over 3. So then our end, of course, we want this to have a common denominator. So this is really 12 pi over 3. And our intervals will be 3 pi over 3. We want all of those to have common denominators. All right, so when we do our start minus our period, we will get -10 pi over 3. And when we add our period, 2 pi over 3 plus 12 pi over 3, we get 14 pi over 3. All right, so now if we go ahead and graph this thing, all right, now my baseline's -4 and my amplitude is 2. So all of my graph is going to occur below the x-axis. So I'll go ahead and do that here. All right, I'm not starting at 0, so I don't necessarily want to put my x-axis in there right away, or y-axis rather. So I'm going to put my start in my middle, which is 2 pi over 3. All right, and then I will have 1, 2, 3, 4 tick marks to the right, and 1, 2, 3, 4 tick marks to the left. All right, of course, as I go to the right, I add my intervals. So this would be 5 pi over 3, 8 pi over 3, 11 pi over 3, and 14 pi over 3, which matches up there, so I'm good. As I go to the left, I keep subtracting my intervals. So here, -pi over 3, -4 pi over 3, -7 pi over 3, and -10 pi over 3. All right. Now, 0 is not on here. Of course, we know 0 lies between a negative and positive number. All right, so I'll put my y-axis on here. Um, it'd be hard for you guys to do it if you have pens or colored markers or something. You could, all right, but I'm going to go ahead and make this a different color, all right, just so that we remember not, oh, son of a biscuit, it didn't do it, all right, just so that we remember not to put a point on it, right? Since it wasn't one of our intervals, when we're going through, we are not putting a point on it. Okay. And of course, we wanted the line a little bit closer to negative pi over 3 than 2 pi over 3 because 0 is closer. All right. Now, my baseline is negative 4 and my amplitude is 2. So I have to go 1, 2, 3, 4, 5, 6. All right. I'll do 7 just for good measure. All right. But my amplitude here, my baseline is negative 4. So that would be here. My amplitude is 2, which means I go up 2 to negative 2 and down 2 to negative 6. All right. This is cosine. So I start at the maximum or minimum, and my a is negative, so I'm starting at the minimum, and my start is 2 pi over 3. So I'm here at 2 pi over 3 and at the minimum. Of course, then I just follow my pattern up to the baseline, up to the maximum, back to the baseline, back to the minimum here. Follow that pattern. Don't put a point on the y-axis because it was not one of my intervals. So now I connect this with a nice smooth curve, as smooth a one as I can get on here. Son of a biscuit. All right. So, but again, we're not doing cosine, we're doing secant. All right. So what we want to do here, there's no 0 here, but that's okay. Our baseline acts as the 0. That's actually what makes this 0 here. Okay. So we still, wherever our baseline points are, all right, that becomes our vertical asymptotes. All right. And then, of course, we just, at our maximums, we make our little parabolic shape above. And at our minimums, we do it below. And that's it. All right. That's how you do secant and cosecant. All right. Now, with tangent and cotangent, I'm only going to do the basics. It's not, these are almost never ever used to model anything in real life. So I don't, really care that we get into like complicated tangent and cotangent graphs. It's really not that big of a deal, I don't feel, for future mathematics. So, but we will look at the parent functions here, if you will, the basic ones. All right, now the easiest way to think of tangent and cotangent also, which we'll get to next, is really to think of it from our identities. A little while ago, we wrote down several identities, of course, our reciprocal identities, our quotient identities, and our Pythagorean identities. All right, well, one of our quotient identities says that tangent of x is equal to sine of x over cosine of x. All right, so this obviously is a fraction, so it works the exact same way as a rational function. All right, so remember when we graphed rational functions, and remember we found the x-intercepts, the y-intercepts, we would do vertical asymptotes, horizontal asymptotes, extra points, holes, that kind of stuff. All right, well, most of that isn't going to apply here, but the x-intercepts and the vertical asymptotes are really all we're going to need. So remember, x-intercepts occur wherever the numerator is 0. So where does sine of x equal 0? All right, well, that happens on the unit circle. That happens at 0. That happens at pi. Of course, we could keep going, right? That happens at 2 pi, 3 pi, so on and so forth. Also in the other direction, right? So negative pi, negative 2 pi, negative 3 pi, right? And then vertical asymptotes occur wherever the denominator is 0. So where does cosine of x equal 0? Well, according to our unit circle, all right, that occurs at pi over 2 and 3 pi over 2. Of course, if you kept going, 5 pi over 2. If you went in the negative direction, right, negative pi over 2, negative 3 pi over 2, so on and so forth. So we can really just graph it really with just those things. So if we have our graph here, of course, we do have an x-intercept at 0. So we do want 0 to be our x-axis here. All right. And of course, you can tell that all of our things are multiples of pi over 2, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So that's going to be what our intervals are going to be here, right? So I can just say 1, 2, 3, 4, 1, 2, 3, 4. So we have pi over 2, pi, 3 pi over 2, 2 pi. Same thing in the negative direction. All right. Y-axis isn't really all that important, but you are going to go way further than just 1. So vertical asymptotes, of course, we can represent with dotted lines, right? So at negative pi over 2 and pi over 2 and 3 pi over 2. Oops, that one's off a little bit. And negative 3 pi over 2. So now we'll just fix these. Come on. There we go. All right. And of course, we have x-intercepts at 0, pi, 2 pi. All right, now, since this is negative pi over 2 and this is positive pi over 2, think of the unit circle, and we are talking about tangent. Well, tangent is positive in the first quadrant, which was between 0 and pi over 2, and negative in the second quadrant, which is between 0 and negative pi over 2, actually fourth quadrant. All right, so our graph is actually going to look something like this. And then they all kind of mimic this. So that's it. That's what cosine looks like. Or I'm sorry, that's what tangent looks like. Whoa, that was awful. And that's it. That's what tangent looks like. They're much more curvy, kind of like this one and this one. This one's not very good, and this one isn't very good, but hard to draw on this thing, so I apologize. But hopefully most of you will be in class anyway and see it done better on the board. All right. Now this one, all right, is just the exact opposite, right? Cosine is actually cosine of x over sine of x. So basically, if we go back up here, all we're doing is flipping the x-intercepts and the vertical asymptotes. So now my vertical asymptotes are going to be at 0, pi, 2 pi, 3 pi, and my x-intercepts are going to be at pi over 2, 3 pi over 2, etc. All right. So I'm not going to spend a whole lot of time on this. Again, I don't think that these are incredibly important. So on the test, you're just going to see like some true false stuff about domain and range and that kind of stuff. So I'll talk about that here in a moment. All right, so again, we have pi, 2 pi, negative pi, negative 2 pi. All right, so our vertical asymptotes occur where the bottom is 0. Well, sine is 0 at 0 and at pi and at 2 pi and at 3 pi, or well, 3 pi also, but negative pi, negative 2 pi, so on and so forth. All right, so in here, I'm not going to get too big into why these things are like they are, but they're kind of the opposite. They kind of come down the different way as the original tangent did. And it has to do just like where is sine positive and cosine positive and where is sine negative and cosine negative. So you can use the whole all students take calculus thing. All right. So basically, between negative 2 pi and negative 3 pi over 2, all right, they're going to be, that would be in the first quadrant, so they're both positive. So a positive over a positive is a negative. Between negative pi over 2 and negative pi, all right, you're going to get one of them positive, one of them negative. That's why you're negative, right? So any place where you're negative, one of cosine is positive and one of them is negative. So a positive over a negative is a negative. And wherever it's positive up here, cotangent is positive, either they're both positive or they're both negative. All right, so that's basically how those happen. And we can look at those a little bit more if you have any questions. But again, really on the test, all you're going to see about tangent and cotangent is some true false stuff about domain and range and zeros, right? So if you just think of it as this fraction, it's really easy, right? So like true or false. The range of cotangent is negative 1 to 1. Well, false, because my range is negative infinity to infinity, right? Stuff like that. And we'll look at some practice true false stuff on your review, which you will get soon as well. All right, well, that's it for today. If you have any questions, please get a hold of me and have a good day.